Conductance is denoted by G, and it is the reciprocal of resistance. This is G is equal to 1 by R, and it is the ease with which electric current flows through a conductor. So the SI unit of conductance, since SI unit of R is ohm, so SI unit of conductance is ohm inverse or mho, MHO. And it is also Simon or capital S. Factors affecting conductance. That is, G depends on length of the conductor. How? It is inversely proportional. Longer the length of the conductor, more is the resistance it offers, and less is the conductance. So G is inversely proportional to L, and G is directly proportional to A, where A is area of cross section. Thicker the wire, more space for the charge flow. So a thick wire will actually have more value of G because it has more space for the charge flow. So conductance increases. Nature of the material. Now the nature of the material is related to the conductivity, which is kappa. So the conductance also depends on the conductivity. Like if there are metals like copper which have very high conductivity, it has high conductance. Insulators have low conductance. Next factor is temperature. How is it affected? For metals, when the temperature is increased, then there is a decrease in the conductance. This occurs for metals. The conductance decreases. With increase in temperature, the randomness of the particles increases. The resistance to the flow of the current also increases. But for electrolytic conductance, this one is for metals, that means metallic conductance. But for electrolytes, with increase in temperature, the ionic mobility increases and so the conductance increases. For electrolyte, increase in temperature will cause an increase in G. Now G is equal to kappa into A by L, where kappa is conductivity and G is conductance. So this is how conductance and conductivity are interrelated. Now basically we can say shorter the length of the material, thicker the length of the material, area of the cross section. That means shorter the material, thicker the material, or better the material will have high conductance. Yes, because conductance is dependent on the conductivity and it is directly proportional. So better material, better conductance. It is directly proportional to the area of the cross section and is inversely proportional to the length of the conductor. That is what you have seen here. So now, conductivity kappa. Conductivity kappa is actually dependent on the type of the material or intrinsic property of the material. Or if I say electrolyte, then intrinsic property of the electrolyte, that is of course independent of the size and the shape of the material. Whichever thing you are taking. Now it is the reciprocal of resistivity. What is resistivity? Resistivity is rho, where rho is R into L by A. Now I said reciprocal of resistivity. So conductivity kappa is equal to 1 by rho. So we can say 1 by R into L by A. Now 1 by R is G, conductance, and L by A is the cell constant G star. So we can say kappa is equal to G into G star. Now, conductivity kappa of an electrolytic solution is the conductance of a solution of 1 centimeter length with area of cross section equal to 1 centimeter square. Now, conductivity kappa is what? Now, it is is the conductance of a solution. Why G it is? Conductance is G. So, G into L by A. So, kappa will be equal to G if L is equal to 1 and A is equal to 1. That means for unit area of cross section and unit length of the conductor, conductance is equal to the conductivity, or it is the conductance of 1 centimeter cube of a solution of an electrolyte. So first part is for metallic conductor and the second part is for electrolytic conductor. SI unit is S M inverse Simon M inverse meter inverse or ohm inverse meter inverse. Okay, factors affecting conductivity kappa. It is dependent on nature of the electrolyte or nature of the conductor. Strong electrolytes that dissociate completely, they have high conductivity, and weak electrolytes, they have low conductivity. Actually, it depends on the number of ions and their mobility. Of course, number of ions and mobility is related, especially number of ions is related to the strong electrolyte. Mobility also depends on the medium. So next is concentration for solutions for electrolytes. Higher the concentration, more ions are there and higher is the conductivity. At very high concentration, ion interaction may slightly reduce the mobility. Now, temperature is another factor. If the temperature is increased, this increases the conductivity due to more ion movement and decrease in viscosity. So, temperature is dependent on the ionic movement, dependent on the viscosity. And so, if increase in temperature occurs, the value of kappa also increases. Nature of solvent. Solvent with high polarity like water. It causes better ionization and has higher conductivity. Next is ionic mobility. Smaller the ions and it has the greater mobility. So highly mobile ions. The smaller the ion, greater is its mobility and higher is its conductivity. H plus and OH minus ions, both, they move very fast and so they have high conductivity. So what we can say by summing up the factors, more the ions, faster the movement of the ions, higher is its conductivity. So conductivity actually depends on number of ions in the medium and also its ionic mobility.